International Baccalaureate Mathematical Studies, truth tables and compound propositions. Problem states, construct a truth table for the compound statement negation of P, inclusive disjunction bracket Q conjunction R bracket. Now before we start, I think it's a good idea to make a few notes about what these things actually mean. A conjunction, which is like an upside down V. Conjunction. Is really the word for and. So it is a conjunction of P and Q. It has to be true for P and also for Q. The inclusive disjunction is like a B, and we call that the inclusive disjunction. Inclusive disjunction, and that is really the word or. So the conjunction is like the intersection in a Venn diagram, and an inclusive disjunction is like the union of two sets. Okay, in the table we've got all the letters that we need. Letters in the problem are P, Q and R, so we need those as they are. But there's also the negation of P, which is there, and we've got the conjunction of Q and R, so we'll need that. And then there's the final thing that we have to work out, which is the negation of P with the inclusive disjunction bracket Q conjunction R bracket. Now the first three columns are quite easy to fill out. You can only have true or false. And you'll see that there are 8 rows, which I've made because I know that that's how many you need. But if we look at how many ways you can write true and false, it's going to be an equal amount of times. So in 8 times there are going to be 4 trues and 4 falses in each column, but they're going to be written in a different way. So I'm going to start with P by starting with 4 trues in order. True, 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 followed by 4 falses, F, 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 and F. So we've got 4 trues, 4 falses. Now Q's can't be 4 trues and 4 falses, but it's going to be the same amount of trues and falses. So this time we're going to put 2 trues, true, true, followed by 2 falses. False, false. 2 trues again, and 2 falses. And finally, the only other alternative I have to put 4 trues and 4 falses in a different way to the first 2 columns is simply alternate them: true, false, true, false, true, false, true, false. And this is a good way to get this down. But essentially you're saying you've got P true, Q true, R true. That's one outcome. Another outcome is 2 trues and a false. A true, a false, and a true, a true, a false, and a false, and so on and so forth. And there's a nice pattern. You've got the top where you've got 3 trues, and you've got the bottom where you've got 3 falses. The top you have, that's where the top at 1 you have 2 trues and a false. The bottom at 1, true, falses, and and a true, two false and a true, and there's a nice symmetry there. But anyway, now we start to fill in the other columns and rows. Now, if P is true, then the negation of P has to be false. So what we need to do for this column is to look at what is said about P in this column and simply write the opposite in this column. So again, the second row, P is true, so negation of P must be false. So two more trues, two more falses. And then four falses, so therefore four trues. And let's be clear about that. If P is true, the negation of P has to be false. If P is false, the negation of P has to be true. Now, on the next one, we've got Q conjunction R. Now this means, conjunction means and. So it's got, if it's true in Q and true in R, then it's true in this column here. If not, it will be false. So we're going to look at Q, and we're going to look at R. So we've got two trues, then it will be true. So yes. So Q is true and R is true, so therefore this compound statement is also true. Q and R, Q true, R false, so therefore the compound statement is false, because only one of them is true. False true, so false again. False false, or definitely false. True true, so that makes that true. And then this row is a true and a false. That's a false and a true, and that's two falses. So they have to be false as well. So we'll just be clear about what we've done there. This statement says it has to be true for Q and true for R. If so, we can write true. If neither of them are true, or only one is true, then it's false. Two trues are true. True and a false, false. False and true, false. Two falses, false. Two trues again, so true. And so on and so forth. And then finally, we come to answer the final compound statement. Now, what this is saying is the negation, it can be the negation of P or Q conjunction R. So it only needs one of them, either this or this, to be true for a true to be written there. So we've got to look at this column and this column. And if one of them is true, then we can write true. If two of them are true, we can also write true. If two of them are false, we must write false. So, false, true, we can write true. False, false, well, false. False, false, false again. False, false, false again. True, 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 true and false. So there's one true, so we can have that as a true. True and false, true, true and false, true. This is probably the most tricky one to understand. But simply think about it as a Venn diagram. This would be the union, so it can be in this or it can be in that. It doesn't have to be in both of them, but it has to be in at least one of them. So if at least one of them are true, we can write true. There we've got a true, one true. But there are two falses, so that has to be false. And the following two are false as well. The final four have all got at least one true. The first of the four has got two truths, so we can write true every time. It's a little bit complicated to understand. Try and understand the conjunction of the two statements are try and see that as the intersection. In the inclusive disjunction, try and see that as the union of two sets, and then you'll be okay.